Located in central Alberta, the city has grown to a population of over 1 million. Due to this expansion and the current economic boom caused by oil and gas opportunities within the province, Calgary's downtown core has been growing right along with the ever-expanding population. The skyline, although unique and beautiful, does resemble those of other major cities around the world. Many of the recently constructed buildings feature a glass curtain design. This feature is achieved by building the structure using almost entirely reflective glass instead of the more traditional stone and concrete walls. Glass curtains are becoming a more and more popular design among current architects. A simple walk through any major city will tell you the same. The stunning reflective surfaces of the buildings are awe-inspiring, the most recognizable example in Calgary being the newly constructed Bow Building. There is, however, a flaw in this feature, as these glass curtains are an unsustainable design that may cost the city millions of dollars in the near future. In order to get a better understanding of what I'm talking about, and why these glass walls aren't made to last, we need to understand first how they are insulated and how that insulation fails over time. Double-paned glass is created by taking two panes of glass and filling the area between with an inert gas, like argon. The area is then sealed to hold the gas in place. The gas acts as the insulator, and as temperature varies on one side of the window, that glass will expand and contract, whereas the glass on the inside of the building should be held at a constant temperature. This means that the seals are often broken over a short period of time simply due to the strain of having one side of glass expand and contract while the other does not. Once the insulation seal is broken, the window no longer retains its insulation value, something we refer to as an R value that we will explain more later in this video. When the seal is broken, heat enters a building very readily, but it doesn't exit the building. This leads to hotter rooms inside, especially on south and east-facing windows. What it also means is that heat can escape from the building more easily, especially on north and west-facing windows. So in terms of sustainability, this means that on the south and east sides, tenants are blowing air conditioning to keep cool, whereas at the same time, tenants on the north and west side of the building have to have their heat on in order to stay warm. This causes an increase in use of electricity and possibly oil and gas to heat and cool the building. An R value is a calculation showing how resistant a material is to temperature changes. The R value of insulation dictates how well a home can maintain a constant temperature and how efficient it is to heat and cool that home. R values range from 0 to 45. The higher R value, the more resistant it is to heating and cooling. Alberta building codes state that exterior walls must have an R value of at least 12. This value is often surpassed by designers, engineers, and homeowners. Alberta codes do not specify, however, a minimum R value for windows. Traditional windows tend to have a much lower R value, ranging between 2 to 8. This means that more heat is escaping in cold climates and more heat is entering in warm climates. This means that using a window as a wall isn't a sustainable alternative. Even in the best case scenario, where a high quality window is used, that would only result in an R value of around 8, 4 less than the minimum code for walls. This difference could result in a fairly substantial amount of energy and money being thrown out the window. For example, if the interior of one of these high-rises was set to 25 degrees and it was minus 15 degrees outside, approximately 5 watts of energy would be lost for every square meter of R8 window. Hypothetically, a building that is 30 stories tall, having one wall 3.5 meters wide of a continuous window, would lose around 1.3 kilowatts constantly. Eventually, this will cost more and more as the insulating properties of the windows deteriorate. In the United States, several states have regulations concerning window R values, but these values are low enough, R 0.26, to really be disregarded. As far as we know, no country has a building code for high R values. So why are we building glass curtain high-rises if they're so bad? Well, honestly, one of the main reasons is that they're very aesthetically pleasing. Another is that glass does last a long time and it's relatively cheap compared to building R12 walls. All they need is glass and a metal frame to hold it in place. Glass is also easily installed. It's mobile. It weighs less than moving stone. It's convenient, and the construction industry gives you a better price. The design community loves it. It's all glass, and there's loads of natural light inside offices and apartment buildings. It's really about the consumer. If people didn't buy glass boxes, no one would make them. To give you an example, CBC Canada stated that on some buildings, 5% of the thermal windows will fail before they're even delivered to the construction site. Another 10 to 15% will fail by the 20-year mark as they're exposed to the physics of heat expansion and contraction. By the 25-year mark, a growing number will fail every year. Imagine the cost of replacing these windows within a 30-year period, and who would take up that cost? In an apartment building, it would be the condo board and the owners. In an office building, it would be the company and the owners. In reality, I think the best decision is to go back to concrete and stone. It might be more expensive, but 100 years from now, we'll have the same classic and beautiful architecture that we had when we built it. Whereas now, these glass curtain buildings will not last any more than 50 years without being replaced. Thank you for listening to this assignment, and we hope that the next time you're downtown looking at the awe-inspiring view from a glass curtain building, you'll also think about the sustainability of that building. Sometimes it's better to go stone.